Okay, I'm going to record this particular presentation, and it's going to be rather short, even though the file is rather long. What I'm doing in this file is I'm going to provide a brief introduction to R Studio, and R Markdown. First, the student needs to install R from the R website found at this particular place here. Next, it's wise to download R Studio. And R Studio is something that I'm currently using, and almost everyone who uses R Studio for its convenience and for the way it works. It can be downloaded from this particular site, and both of them are free, although you can get an upgraded or professional version of R Studio. If you use R Studio, you will get this screen, which is the one that's currently open here, and you can see that it consists of 4 panels. The panel here that I'm waving my cursor in is simply the panel in which the editor is to be found, and I can move this up and down like that. This here is the console, but you can also look at jobs and other kinds of things going on. This area here is where you're going to get some global output. For example, if I run a file, and we'll see that shortly, which creates a matrix, the matrix can be found in this corner here, but you'd have to double click on it, in which case it'll then show up in this screen here. And this important area down here is important for a number of reasons. One, it gives you all the files that are in the current directory. It'll give you the plots. When you do a plot, you can pick out the plot here, and you can export it using this export tab. And importantly, it is used for packages. So these are all the installed packages, and there might be packages that don't automatically come with the default version of R and R Studio, and then you'll have to install them. And you do that by hitting install, writing the name of the package in here. For example, I might use R Markdown. So I have Markdown here, but it's already installed, so I don't need to do it. But if I click on it, then I can install it, and I want to install all of the dependencies as well. All right, so let's look at some briefly what can be done. First off is that when I'm writing in R Markdown, and I don't need to use R Markdown to do this, but I'm doing it so that you get some idea of how R works. So in other words, you have to install the package R Markdown, and then you go up here and you open a new project or a new file using R Markdown. So that's, otherwise you would use the regular R script here. Whoops, there, R script here, or you can use R notebook. I've never used that, and so on down. One reason that I like to use R Markdown is because I can knit this file. Everything that I do, I can hit knit to HTML, to PDF, or to Word, and that means I create this document as a PDF, HTML, or Word document, and then I can do with it as I would a normal PDF or even a Word document. The other thing is that this is LaTeX. So I have to learn how to do word processing in LaTeX. For example, here is an equation that I structure, and you can see a little later on what that looks like when I actually knit this file together as a PDF or Word, and that I'll put on the bright space place for the Econ 351 course. Now, the other thing to note is that you'll see here in gray is actual R code. Now, when I want to knit this together and create that Word or PDF, but I don't want this to show, this gray stuff to show, I have to put in echo false. Now to get this particular gray stuff, I go into the white space here and I hit Control-Alt-I, and that will automatically create a place where I can enter code. I can also do that by inserting chunk. So we call these chunks of code here. And when I insert a chunk of code, what will appear is these three little dashes, and they are found under the escape key on my keyboard, where I have a squiggly line, and underneath it is that little marker that they use, three markers, and then this left curly bracket and the right curly bracket, but not with the echo equal false in there. Notice that the echo equal false is used to prevent printing of the code that generates the outputs. So that's the first thing. The other thing is that I can change this R to C or Python, and you'll have to Google that or find that out in the markdown file. And that implies that you can run R code and C code and Python code in or within the markdown framework. So they can run, you can take a piece of Python code, say, and put it in there and run it. Now, I'm just going to briefly talk about how R works, because now we're getting into the programming. So suppose I want to create a matrix A. The first thing you'll notice is that I've got a less than sign followed by a hyphen. And that means I'm assigning something to A. I could reverse that sign, having the hyphen first and then a greater than sign. And for example, I would have, let's say instead of a matrix, I want to put a number. So I'll have A, the less than sign hyphen equals 12. That'll assign 12 to A. I could also have 12 hyphen greater than sign and then A, and that assigns the 12 into A as well. A third way to do it is just to use an equal sign. Now, I don't know why programmers tend to use this and ignore the equal sign. I use a combination of things. Now, we're going to assign this matrix to A. Now, how do we form a matrix? Well, the first thing you notice is this little C here. That C is required whenever you use more than one particular number. So here I've got C is 43, 12, 35, 16, 3, 2, 8, 11, 5. And I then declare the number of rows and the number of columns. And then I have to put by row. If I don't put by row as true, then I get the first row being 43, 16, and then 8. And the first column then would be 43, 12, 35. But I want 43, 12, 35 to be the first row, 16, 3, 2, and 8, the second, and so on. If I want to print A, down in the console, so for example, I can go Control Enter, and that will run the first piece of code. You'll see it here, down here. I could go Control Alt A and run the entire chunk, and these are referred to as chunks. I can also go here and run it. And I can put there, run all chunks above this one, or run the current chunk of code. So now, if I hit A, so I've run the first one where A is created by that matrix. Then if I hit A, notice that down below here, I've created that A matrix the way I want it. All right. Now, if I want a particular element of A, so the second row and the third column is a 2 down here. There's your 2, and this is how I then identify that 2. So if I want to identify a particular element in the matrix, I need to use that. So now I'm going to create my mat, and that's a matrix with 30 rows and 30 columns. When I run this, I get a matrix like that. And notice that it shows up over here as my mat. And it's a 30 rows 30 columns, and they're empty. So it's basically a matrix with zeros in it. Now I can also bring up that A matrix by double clicking on it, and you'll see that it appears up here in this form up there. It's not a nice form, but that's how it will appear. So now I'm going to use a loop, a double loop. I'm going to have 4 and then a bracket, I in 1, 2, and then dim m my mat 1. So that's the first dimension. Remember this way of coding it. So I want to have the first dimension. The first is the row dimension. I use this left squirrely bracket, and I use the ending squirrely bracket to take into account the next one, which is j in this dimension 2. So by running this, so if I'm going to hit Control Enter, it's going to run that whole piece there, and I'm going to hit Control Enter again, and I get the matrix down here. But I'm only asking it to run the first 10 rows and the first 10 columns. We can concatenate a matrix, or we can match, combine matrices and vectors, or vectors and matrices. And let's say we create a new vector here, which is a text vector, so a vector of texts, and we call them cat, dog, and horse, and we can print that out if you like. So we're going to run this a minute, and we're going to down here, because I haven't got it, so we'll go VV, and you can see cat, dog, horse down here. All right. Now, concatenate, what I want to do is I want to create a new vector, or a new matrix, which takes the VV vector and puts it on top of, so it's a row on top of A. So if I do that, if I run that and then go down here and I want to see it, or I can see it here. Okay, you see that I have cat, dog, horse, and I've concatenated them. But this is not a nice way to look at it. So what I want to do is create a data frame. And data frames are used mainly for statistical analysis, but they're also handy for other things. And now I've got CC, and let's see what that looks like. This is my data frame. Notice that I've got these X1, X2, X3. All right. Now, we can also embed an answer right into the text. So here's an example of a previous matrix where the element of the 10th row and the 9th column equals, and I've embedded that using this little chunk of code. All right. And you'll see that when I create the Word or PDF file, which I'll put on the Brightspace for the course. Next, we'll look at the inverse of a matrix. That's done using a solve, because we usually assume something along the lines of AX equals B, and we want to solve for A or something. The thing to recognize here is that matrix multiplication requires that you have percent star percent. So if you don't have the percents on each side, what you're doing is element by element matrix operations. So you're multiplying element 1, 1 of the inverse of A times the element 1, 1 of A, element 1, 2 of inverse of A times element 1, 2 of A. You're not doing pure matrix multiplication as you know it, where you take the sum of a row and a column multiplied, each of the elements multiplied by each other and summed. All right, we also have eigenvalues of A. Recall that we need these eigenvalues and the eigenvectors of A to solve systems of difference or differential equations. And this is shown here. I've already run this chunk of code. So this is the inverse matrix. of A. This is the matrix, the identity matrix, and you'll see that it's an identity matrix. If you look at these minus 16, this is 0, this one's minus 17, minus 17, minus 16, minus, so these are to the power, which is essentially 0. So you have basically on the diagonal the ones. Here is the eigenvalues. These are the eigenvalues, and notice that they're complex numbers. Here, these 3, and these then are the eigenvectors, the 3 eigenvectors. We can also plot. I'm not going to spend a lot of time on that. You can look at the plotting, the arguments, and there are 2 ways to plot. You can do a curve this way, and in this case, what we do is we add, so we create one curve, and then we put on the same diagram, we put the second curve. So the first one is x cubed minus 3x, which is the black line. And then the curve x squared minus 2. We add it to, you need this little statement to add it to, and then you get the red line. All right, we do the same thing with a sine and cosine, and we plot them on top of each other. Here we have a rather odd looking function, which is sine of a cos of x times e to the minus x over 2. And you see that this gets a fairly funny looking thing there. And notice that we put the minus 8 to 7. So in other words, minus 8 occurs right in this area, and over here is our 7. We also have a couple of curves here where we end up not putting the add true. All right, we don't have add true. So in other words, you get first one function which is like that, and then the other function. So they're separate. If you want them on top of each other, then what you have to do is use that add equals true. All right, linear programming. We use the package LP-solve to solve linear programming problems. This implies that after we've installed the package, we need to call it using the following code. So we've installed LP-solve, then we use library LP-solve to call that package so we can use it. So here's an example of a linear program, a problem. And here's how we solve it. So we first get library LP-solve, then we define the 0.67 and the 1, 0.67 and 1. Then we have this matrix 1, 2, 1, 1, 1, 1/2. And then we got these here, x greater than or equal to 0 and y greater than or equal to 0. So we get a 1 and a 0 and a 0 and a 1 to cover these two. So you see that here when we create that matrix, which is often called A. And then we have 5, 1, 2, 3 constraints. 4 is the x greater than 0, 5, y greater than 0. So we want that dimension to be 5 by 2. And we do it by row equals true as we showed up above. Then we have the right-hand side constraints, which are 14, 10, 6, and 2 times 0. 14, 10, 6, 2 times 0. We also need to define the direction that these inequalities take. The inequality constraints are all greater than or equal to constraints. And then we want the value of the objective. So we run the optimization 1, and that assigns the LP solution to optimization 1. And this is how we do that. And we can then call the optimization 1 and the optimization 1. We can just pick the solution. Dollar solution would give that. And we can look at the shadow prices or the duals as they're called. Okay. And this gives the solution here and the duals over here. The objective function rather is 8.02, x is 6 and y is 4. And then the dual values are 0.33 and 0.34 and these relate to these other parameters. A second example, I'll let you work through that on your own and figure it out. And that is all that we're going to do here for. Thank you for watching this video. There are many more videos in this 2 to 3 course series. A list of videos, the order in which they should be taken, and links to them are found under Mathematical Economics at the website indicated below.